Hi everyone, in this video we're going to talk about distance and how do you find the distance between any 2 points. Okay, so to do that we're going to talk about 2 different methods, Pythagorean Theorem and distance formula. The first 2 examples I'll do one of each, and then if you prefer Pythagorean Theorem you can skip over to the next Pythagorean Theorem example, or if you prefer the distance formula you can go to the last example, which is the distance as well. So I'll do Pythagorean Theorem, distance formula, Pythagorean Theorem, and distance formula. I'll solve 2 problems on 2 ways, so you can try it both out and see which method you prefer. Let's get started. So, Pythagorean Theorem is something that you discussed in 8th grade, and this is the formula you did. We have a squared plus b squared equals c squared. Whenever you have a right triangle, and we'll talk about this much more in detail later, a and b are the legs of the triangle. And you can choose this to be B and this to be A. You can alternate them. The only one that has to be for sure, the diagonal, is the only one that is fixed, and that's going to be C. Those are the values that we're going to be using for this formula. The distance formula, I'm going to switch colors here. We learned in Algebra 1, and this is the formula. We take the square root of x2 minus x1 squared plus y2 minus y1 squared. So what you do in the beginning is you choose your points. You're going to have 2 points, and you're going to label them as x1, y1, and as x2, y2. Once you have them labeled, our goal is to plug them into the formula and find the distance. Okay, so for this, to use this formula, you can use Desmos or a calculator, a graphing calculator that will simplify the steps a little bit. Over here, for the Pythagorean Theorem, you're starting off with the 2 points. You start with the 2 points, and you create a right triangle between them to find those lengths. Let's get started with Pythagorean Theorem. So here you have an example. Find the distance between points K and F. Now I already drew it. Feel free to pause the video, draw it yourself, and follow along with me. So we have point K is at 2, 3, and F is at 4, 4. Because it's Pythagorean Theorem, I'm going to create a triangle between these 2. The triangle will help me find and measure certain distances. Okay, so the formula says a squared plus b squared equals c squared. Remember, the only thing that is fixed is the hypotenuse. The other ones could be A and B. And I'm going to count. I'm going to start here. I'm going to count this side of the triangle, and then count this side of the triangle. Horizontally, I have 1, 2 spaces. And vertically, I have just 1 space. And I'm going to plug this into the formula. So I have a squared, which is 2 squared, plus b squared, which is 1 squared, gives you c squared. As I start squaring numbers, 2 to the second power is going to be 2 times 2, which is 4. 1 to the second power is 1. And that equals c squared. When I combine everything on the left, 4 plus 1 equals 5, equals c squared. And now, the thing that you do have to remember is that to get rid of the square, we need to do the inverse. The opposite of squaring is square rooting. So we take the square root of the right, the square root of the left, and that leaves you with c equals, and I'm going to try this out here real quick on my calculator. The square root of 5 is going to be 2.236-ish, approximately 2.236. Okay, this is how you do it using Pythagorean Theorem. Now, if looking at the picture and counting and drawing the picture is too much, then let's try the distance formula. The exact same problem. All right, we know our answer is going to be 2.236, but now we're going to do it a different method. I'm going to start by labeling my points as x1, y1, x2, y2. x1, y1, x2, y2. Once I label them, I substitute them into my formula. So I have d equals the square root of x2, which is, I'll put this in red, x2 minus x1. So I have 4 minus 2. Plus, let's use another color, y2 minus y1, 4 minus 3. Squared. Now here, you can literally put this part of the equation, everything you see here on the right, this square root part, into Desmos, and it'll give you the answer. As long as you don't forget the parentheses and the exponents where they belong, and the fact that the square root goes all the way to the end, then you should get the same answer. Or you can follow along using PEMDAS, where you start with parentheses, and we simplify inside the parentheses first. We get the square root of 4 minus 2 is 2. 4 minus 3 is 1. And then we do exponents from PEMDAS. 2 squared equals 4. 1 squared equals 1, which gives us what we saw earlier. The square root of 4 plus 1 is 5, which is approximately, I'm going to round here, 2.236. So you decide, do I prefer to use the graph where I draw a triangle and count some spaces, or do I prefer the distance formula? And remember, at this point, you can use Desmos calculator. You can go to Desmos. If you want to find Desmos, you can find it under resources in my Schoology. Or you can just go to desmos.com/calculator. If this was enough to understand the topic, then you're good to go. But in the next half of the video, I'm going to pose another problem where we solve a Pythagorean theorem and then the same problem using distance formula. And feel free to try another one just to solidify your understanding. Okay, so here we're trying to find the distance between C and Q. I want to find the distance using Pythagorean theorem, right? So Pythagorean theorem, I have to do my triangle. I have to draw it. So I'm going to draw a triangle here. And my formula is a squared plus b squared equals c squared. All I have to do here is count. Remember that diagonal is c. That's what I'm trying to find. So if I count horizontally, here I only have one space. And if I count vertically, I have 1, 2, 3, 4 spaces. The good thing about using Pythagorean theorem is that I don't have to worry about dealing with negatives. I don't have to remember the rules of subtracting or adding negatives or any of that stuff. I just have to count. Count one space, count 4 spaces, and then plug them in for your A and B. So for A, we get 1 squared. For B, you get 4 squared equals c squared. 1 squared is 1. 4 squared is 16. 16 plus 1 is 17 equals c squared. And remember this last step, to get rid of the square, we need to do the opposite. The inverse is square rooting both sides. The c would equal the square root of 16, or 17, which is approximately 4.123. I'm rounding, so it's approximately. All right, there's Pythagorean theorem. The thing I like about Pythagorean theorem is I can just count the sides of a triangle. I don't have to worry about the rules of negatives. If you're fine with negatives and you don't like the picture, you prefer the formula, stick out to the next problem. This next problem, we'll do the exact same problem using the distance formula. All right, here we have the exact same problem. We first start by labeling it as x1, y1, and x2, y2. Once you label your points, it's about plugging it into the formula. So d equals the square root of x2 minus x1. So we have x2 minus x1. It has to be in that order. -2 minus -3. You gotta be really careful here because you're subtracting a negative. So I got to put two minuses here, subtracting -3. And then we have plus y2 minus y1. Now the y2 is 3 minus -1. Minus -1. Now these minus and negatives, if you remember your rules of negatives and positives, when you subtract the negative, it changes it to a plus. So this minus and negative is really a plus sign. And the other minus and negative is also a plus sign. Okay, this is why I said the Pythagorean theorem might be easier for some people, because with triangles, you don't have to worry about negatives. You just have to count spaces. Pythagorean theorem, distance formula, you definitely have to know your rules and how to combine them carefully, because then the signs matter and they change everything. Let's keep solving. Again, this is the part where you can go to Desmos, if you prefer. Desmos will take care of the rest, or you can solve it by hand, which I will do. Inside the parentheses for PEMDAS, we have -2 plus 3, which is +1. 3 plus 1 is +4. Now I go into exponents. 1 squared equals 1. 4 squared is 16. I combine the inside now because addition. 1 plus 16 is 17. And this last piece, I have to go to the calculator. The square root of 17, if I round, is 4.123. So there you have it. We did 2 examples using 2 different methods. You pick whichever method you feel more comfortable with, the one that you gravitate to easier the most. If you struggle with both, try both out until you find one that you start feeling better with, and then practice that one, right? Feel free to pause the video, rewind it, try these again, so that you can have a better understanding of the examples that we're doing. All right, guys, let me know if you all need anything, and as always, we'll calculate later.